In this video, I'm going to review a new force, which is the normal force, and then also present a visual organizer to help you do force problems later on. So our objectives today are to identify the normal force, and when we say normal force, we're not talking about natural or typical, we're talking about normal as a math term. And then also be able to draw the normal force in the correct direction. So the hard part for you, or your challenge today, is to take the definition you have in your brain for the word normal, and we're going to create an entirely new definition. So before we do that, we're going to start with this idea of the center of mass, because all forces that we are looking at operate on the center of mass. When you have a symmetric object, the center of mass is dead in the center of mass. But when you have an asymmetric object, the center of mass is either right above the balance point or right below the balance point. And if you want to find the center of mass of an object, the typical thing to do is to hang it. You'll draw a line, and then you hang it from a different place and draw another line, and then hang it from a third place and draw another line, and where those three lines intersect is the center of mass. Don't need to worry about that, just know that forces act at the center of mass. So for example, weight acts at the center of mass. So when we think about the force acting on this object, we can think of it acting as though all of the mass were a single point in the center of the object. And so that's just like a nice to know thing that forces, we assume they act at the center of mass of an object. So we're introducing this new type of force. We've looked at weight force previously. Now we're looking at something called normal force or support force, although it's not always a supporting force. But the idea is that when you have two solid surfaces that are in contact with each other, they exert a normal force or support force on each other. So another thing to recognize is that surfaces always push, they never pull. So we've got this barbell and it's sitting on the table. The table is pushing upwards, okay? That's what we show here. The table is pushing upwards at the point of contact. Now, the normal force, and that's this force going up is the normal force, but it doesn't always point upwards. Normal means perpendicular. And so what that means is that normal forces always point at right angles to the surface. So when my surface is horizontal, my normal force is either going to point straight up or straight down, depending on where the object is. The thing that's essential to keep in mind is that normal forces means perpendicular to the object. So, and the idea that we've been looking at is that if you know the forces acting on an object, you can predict its motion. So if we look at this object, we know that it's touching a surface right here, and so we're going to have a force pushing away from the surface to the ball perpendicular, so it goes in this direction. The ball is also touching right here, and so again we think about that is my surface, and so therefore the normal force is going to be acting perpendicularly to the surface, and so that is that one right there. So some things to keep in mind about the normal force. Every contact with a surface creates a normal force, or in other words, anytime you have two solid objects in contact with each other, there is a normal force. So this surface and the ball, normal force, again perpendicular, going straight up. Normal forces may be vertical, horizontal, or act at an angle, but they are always perpendicular to the surfaces that apply them. So we've looked at these two. This surface is contacting the ball here. Perpendicular line looks like that, and so normal force from this surface points in that direction. Here we have another surface in contact with the ball. Here's the surface, perpendicular is going that way. Okay? So those are two forces. They are perpendicular or normal to the surface that is contacting the ball. So we're going to do a bunch of practice. All right, what direction does the normal force on the ball by surface 1 point? Here's surface 1. What direction does the normal force point? All right, perpendicular to the surface is going to be in this direction. And I would say that is up and right, and so the answer is going to be B. What direction does the normal force on the ball by surface 2 point? So here's surface 2. Here's my point of contact. Perpendicular to that surface is going to be directly left. So the answer is G. What direction does the weight force on the ball point? Weight force acts in the middle, always goes straight down. So the answer is E. What direction does the normal force on ball 1 by ball 2 point? Okay, so we're looking at the force on 1. It's actually going to be, we can think about, this is my point of contact, and the force is going to point in that direction perpendicular to where they contact. And this is actually along the line that connects the centers of mass. So that is going to be left and down. What direction does the normal force on ball 1 by surface 1 point? Okay, surface 1 is over here. That is my surface. Here's the point of contact. It's going to go perpendicular to the point of contact, perpendicular to the point of contact, and so that is going to be directly right. Again, remember, it's always a push away. What direction does the weight force on ball 2 point? Weight forces always go straight down, and so that is going to be E. What direction does the normal force on ball 1 by surface 2 point? Here's the surface, here's the point of contact. Perpendicular is going to be straight up. What direction does the normal force on ball 2 by ball 1 point? Okay, this is going to be just the opposite direction that we had before. There's my point of contact. The normal force goes along the line that connects the centers of mass, so it's going to go that way. What direction is the normal force on ball 2 by surface 3 point? Surface, point of contact, perpendicular to that surface is that direction. What direction does the normal force on ball 2 by surface 3 point? Okay, for some reason I have that question twice, so we will skip it. What direction does the normal force on ball 2 by surface 1 point? It's actually a trick question because ball 2 does not touch surface 1, so there cannot be a normal force. So there has to be contact between the two surfaces in order for there to be a normal force between them. So if we summarize, normal means perpendicular to the surface at the point of contact. It does not mean typical, it does not mean natural. If you use anything else for n other than normal, that will be wrong. Normal force occurs anytime there is a contact between two solid objects. So anytime there's two solid objects touching each other, there's a normal force. Normal forces can point in any direction, but it's always perpendicular to the surface at the point of contact. The symbol for normal force is F with a subscript n. If you want to, you could also go F with the perpendicular mark. If that helps you remember that it's perpendicular, you can use that instead. Okay, so our objectives. Can you identify normal forces? When do they occur? And can you draw a normal force in the correct direction? Let's go ahead, put 1, 2, 3, 4, or 5. Okay, so this one I said was a trick question, and we have kind of a visual aid to help us know what things are interacting with each other and whether or not there's going to be a normal force. and we do something called a system schema or the bubble diagram, and it visually represents which objects are interacting with each other, and that will help us solve force problems. So the first thing you do is you put all objects in bubbles. So we've got ball 1, you write it out, put it in a bubble. Ball 2, bubble. We've got surface 3, bubble. We've got surface 2, bubble, surface 1, and we've got one more thing that we always have, and that is the earth. All right, so that's the first thing, put all the objects in a scenario into bubbles. The next thing that you're going to do is you draw lines connecting the objects that are touching each other or interacting with each other. So ball 1 is touching ball 2, surface 1, surface 2, and it's also interacting with the earth. After I draw interactions, or while I'm drawing interactions, I usually like to label them to make sure that these are genuinely interactions. That is contact, so that is normal, that is normal, that is normal. This, however, is weight. So that's going to be FW or FG. Ball 2 is interacting. In addition to ball 1, I do not draw a second line to ball 1. It's hitting, it's not hitting surface 2, is it? It is only hitting surface 3 and the earth. If you want to draw, and so we'll label those so we know that this is normal and this is weight. If you want to draw in kind of the support structures, so surface 1 interacting with the earth, because everything interacts with the earth, you can do that, but that is a system schema. Let's do another one. So we've got a cat is motionless on a rug. So we know that we have the cat, we have the rug. Now we have something that's implied, which is the floor. You can either put that in a separate bubble or you can put it in the same bubble as the earth, either one. So cat touching the rug, normal. Cat interacting with the earth, that's weight. And then the rug is interacting with the floor. And this is why I sometimes put them in separate bubbles. Rug also interacting with the earth, which is weight. So that's all you're going to do for the worksheet for today is create system schema.